Hello friends, welcome to our channel. I hope you are all good and you are all focused on your studies. Thank you for joining me today. Today we are going to solve the remaining part of the chapter of the exercise 3.2 from the book Ganit Prakash of class 10. So we have already completed up to question number 8. Now we are going to solve question number 9. Question number 9, it says the two circles with centers x and y intersect each other at the points A and B. A is joined with the midpoint S. Okay, so we have two circles with centers x and y. They intersect at points A and B. A point is joined with the midpoint of xy, which is S. So AS, and a perpendicular on SA. Okay, so this is the perpendicular on SA. PQ is a perpendicular on SA. So and which cuts the two circles at P and Q. We have to prove PA equal to AQ. This part is equal to this part. We need to prove that. So you can write the given part. We have two circles with centers x and y. They intersect each other at points A and B. S is the midpoint of xy. PQ perpendicular to AC. Now, to prove PA equal to AQ, construction, drawing a perpendicular XL on PA and drawing another perpendicular YM on AQ. Proof. PA is a chord of the circle with center X. XL perpendicular to PA. Therefore, XL bisects PA. XL bisects PA. Therefore, PL equal to LA. And AQ is a chord of the circle with center Y. YM perpendicular to AQ. Therefore, YM bisects AQ. So this part is equal to this part and this part is equal to this part. AM equal to MQ. So we have got PL equal to LA, AM equal to MQ. Now we know if we have we can say XL, SA and YM are parallel to each other because they are perpendicular to the same line. They are perpendiculars to the same line. Therefore, they are parallel. So this thing is parallel to this thing is parallel to this thing. Now we know if we have three parallel lines, L1, L2, L3, and if we have two transversal, this is transversal 1, this is our transversal 2, we know that if three parallel lines are cut by two different transversals, and if this part is equal to this part, then this part will also be equal to this part. We have done this theorem before. Okay, when three parallel lines are cut by two different transversals, and when a transversal creates equal segments, then the other transversal will also create equal segments. Okay, so if three or more parallel lines are cut by two transversals, the segments formed on the transversals are proportional always. So if this part is equal to this part, then this part will also be equal to this part. Okay. So similarly, in this case, S is the these are three transversals. Okay, and PQ and XY are these are three parallel lines. Okay, XL, XA, XL, SA, and YM are three parallel lines. Which are cut by two transversals. PQ and XY. XS is equal to SY. It is given that this part is equal to this part. It is given S is the midpoint of XY. It is given in the question. So XS is equal to SY. Therefore, we can say LA should be equal to AM. Now, if we multiply both sides by 2, it becomes 2 into LA, it becomes 2 into AM. Or 2LA. Okay, LA equal to PL. These two parts are equal, so we can write 2LA is actually PA and 2AM is equal to MQ. AM is equal to MQ. That is why we can say AM 2AM is equal to AQ. So this is what we needed to prove. I hope you understood. You have understood the question, the solution. Now let us proceed to question number 10. Question number 10 says the two parallel chords AB and CD with lengths of 10 cm and 24 cm in a circle are situated on the opposite sides of the center. Okay. If the distance between two chords AB and CD is 17 cm, then find the radius. Let us say this is our AB. which is 10 centimeter, and another chord CD, which is 24 centimeter. And the distance between the two chords, this part is 17 centimeter. Then find the radius. Let us join these 2 points. Join OD and OB first. Then let this is P, this is Q. Let OP is equal to x centimeter. Therefore, OQ equal to 17 minus x. Why? Because the total length is 17 centimeter. So this part is x. So this part will be 17 minus x centimeter. This is our radius r. This is our radius r. Now OP perpendicular to CD. Therefore, OP bisects CD. Therefore, PD equal to half of CD, which is 12 centimeter. OQ perpendicular to AB. Therefore, OQ bisects AB. Therefore, QB equal to half of AB, that is 5 centimeter. Now, in triangle OQB, hypotenuse square equal to perpendicular square plus base square. In triangle OPD, hypotenuse square equal to perpendicular square plus base square. Okay, so this is the value of r square and this is also the value of r square. So we can equate these two things and solve x. Therefore, we can write So x equal to 5. So the radius, the length of radius will be, we can put this value into any of these equations. So r equal to root over x square plus 12 square 144. So the radius is 13 centimeter. So I hope this question is clear to you. Now let us proceed to next question, question number 11. Question number 11 says we have two circles with centers P and Q. They intersect each other at points A and B, and a line segment which is parallel to PQ passes through A and cuts these two circles into C and D. Now we have to prove CD equal to 2PQ. Now let us do one thing. You can write the given part. So we are drawing two perpendiculars. Proof. PX perpendicular to the chord CA and PX perpendicular to the chord CA. Therefore, PX bisects CA. Therefore, CX is equal to XA. Similarly, QY perpendicular to AD. Therefore, QY bisects AD. Therefore, AY equal to YD. And PX parallel to QY. This is parallel to this. Why? Because both of them are perpendicular to the same line CD. So PX parallel to QY and XY parallel to PQ. It is given CD parallel to PQ, that means XY will also be parallel to PQ. So therefore PXYQ is a parallelogram. Therefore, we know opposite sides of the parallelogram are equal. Therefore, we can say XY should be equal to PQ. Now, XY is equal to PQ. XY means XA plus AY equal to PQ. In place of XA, we can write half of CA. Because this part is equal to this part, we have proven it. Cx equal to xa, this part equal to this part. That means total Ca to xa will be half of Ca, and ay can be written as half of AD. Now we are taking half common, and transferring 2 to the right side. So Ca plus AD is actually CD. So this is what we needed to prove. I hope you all understood it. Thank you friends for watching my video. If you liked it, please support me. You can like, share or subscribe to my channel. We shall come with another video where we shall be solving the rest of this chapter. If you have any doubt or question, you can leave that in the comment section. Thank you friends.